Welcome to Bethelmatics Academy. So this lesson is a continuation of the previous video where I taught you understanding quadrants and measuring angles. So if you have not watched that video, please do it to watch that before this one. In that video, I'll show you how to identify whether an angle is in the first quadrant, second quadrant, third or fourth quadrant. So in this very video, we want to learn about the nature of trigonometric ratios in each of the quadrants. Whatever value that is given to us, we are going to express it as an acute. Then we're going to tell whether the trigonometric ratio that is formed in that very quadrant is positive or negative. Okay, let's first of all consider the nature of trigonometric ratios within the first quadrant. For an angle to be within the first quadrant, that angle must be between 0 and 90 degrees. So let's draw our quadrant. Now, since we are dealing with the first quadrant, that means theta is within the first quadrant. The angle that is formed, theta, and it is within the first quadrant. So let's call here R. Now, for us to understand the nature of trigonometric ratios within this first quadrant, we're going to produce a right-angled triangle. So let's produce a right-angled triangle this way. So if this line is y, this line is also y. Okay, let me call here A. So it simply means that OP is R, OA is X, and AP is Y. So since we are dealing with the first quadrant, X is positive. This is positive X, and this is positive Y. Then this Y is also positive. Of course, R is positive. So now let's now know what is the nature of sine, cosine, and tangent in this very quadrant. So remember your mnemonic, SOHCAHTOA. Okay, so this mnemonic will get us sine is opposite of hypotenuse. So let's know the nature of sine in this very first quadrant. Sine theta is equal to opposite over hypotenuse. That is y over r. Since y is positive and r is positive, positive divided by positive is positive. So therefore, sine theta is positive. So let's go to cosine. Number 2, cos theta. Of course, cos theta. Remember, cos is adjacent over hypotenuse. So cos theta is adjacent over hypotenuse. That is x over r. So this is x over r. So since x is positive, r is positive. So positive divided by positive is positive. So it simply means that cos theta is positive. Then the last one, tan theta. Tan theta is giving us opposite over adjacent. So this is opposite, this is adjacent. So y over x. Y over x. So therefore, positive divided by positive will give us what? Positive. So tan is also what? Positive. So it simply means that within the first quadrant, everything is positive. So I can say all. Let's move to the second quadrant and understand the nature of trigonometric ratios in the second quadrant. Okay, so for an angle to be in the second quadrant, that angle must be between 90 degree and 180 degree. So the next thing to do is to draw our quadrants. So it means that this is theta that led us into the second quadrant. Okay, so let's call this acute angle alpha. Please note that the acute angle we are going to be dealing with must be the angle made with the horizontal line. Alpha is an acute angle, and if I want to get the acute angle equivalent of the theta that was given to us, then from here to here is 180 degree. That means alpha is equal to, from here to here is 180 degree minus from here to here, which is what? Theta. So whenever I want to convert theta to acute, I will just say 180 minus theta. It converts to acute for whatever angle that is within the second quadrant. So let us now know the nature of the trigonometric ratios within this second quadrant. So the first one is sine alpha. which is something as sine 180 minus theta. Sine alpha is what? Opposite of our hypotenuse, which is equal to y over r. So therefore, sine alpha in this case is what? Positive. Number 2, cos alpha. So in this quadrant, cos is adjacent over hypotenuse. This is minus x over r. Negative divided by positive will give us negative. So this is negative as minus cos alpha. Number 3, let's see the nature of tan. Tan alpha is opposite over adjacent. So tan alpha is equal to opposite, which is y, over adjacent, which is minus x. Of course, positive divided by negative will give us negative. So therefore, we have here is going to be minus tan alpha. So that means in second quadrant, only sine of an acute value is positive. So here, only sine. So let's now know the nature of the trigonometric ratios of acute values in the third quadrant. So for this angle to be in the third quadrant, the angle must be between 180 and 270 degrees. So this is in the quadrant. Let's draw. Theta was given to us that brought us to third quadrant. This is theta. And this is the angle of interest, alpha, that is acute. From here to here is 180 degrees. But from here to here is theta. So for us to get the value of alpha, is going to be theta minus 180 degrees. So alpha is equal to theta minus 180 degrees. These formulas are very important to be able to convert whatever value that is given to you into a value that is acute in whatever quadrant you find yourself. Okay, so let's now know the nature of the trigonometric ratios in this very third quadrant. The first one is sine alpha is equal to, remember, sine is opposite over hypotenuse. Okay, so sine alpha is what? Opposite over hypotenuse. That is minus x over r. Of course, negative divided by positive is what? Negative. So therefore, our sine in the third quadrant is negative. Let's go to cosine. Cos alpha is equal to, cos is adjacent over hypotenuse. That is minus y over r. Minus y over r. Negative divided by positive is negative. So therefore, cosine of an acute angle within the third quadrant is negative. So let's go to the third one, tangent of alpha. Tan alpha is equal to, tan alpha is what? Opposite over adjacent. So minus x over minus y. Minus x over minus y. Minus, we cancel minus, so that we now have it as x over y. So this is plus tan alpha. So that means within the third quadrant, only tangent of an acute value will give us positive. So it means in the third quadrant, only t tangent is positive. Then let's now go to the fourth quadrant. For an angle to be in the fourth quadrant, that angle must lie between 270 and 360 degrees. So it simply means that 270 degrees is less than theta, which is less than what? 360 degrees. So let's draw the fourth quadrant. For an angle to be in this fourth quadrant, it means that theta must be more than 270 degrees. So this is our theta, which brought us into fourth quadrant. So this is our 90 degrees. So this remaining angle, the angle that this line OR makes with the positive axis, is alpha, as I've always used. So to find the value of alpha, go to 360 minus theta. So alpha in this fourth quadrant is equal to 360 degrees minus theta. We're going to be using to find acute value equivalent in fourth quadrant. Our sine alpha is opposite over hypotenuse. That is minus y over r. Negative divided by positive is negative. It means that the sign of an acute value in the fourth quadrant is negative. So let's go to the second one. Cos alpha. Cosine is adjacent over hypotenuse. That is x over r. X over r. So therefore, positive divided by positive is positive. So this is plus cos alpha. And then the third one is tan alpha. Of course, tangent is opposite over adjacent. So our opposite is what? Minus y divided by x. Minus y divided by x. So negative divided by positive is negative. Tan is negative. So in the fourth quadrant, only cosine, only cos is positive. In this question, we ask express each of the following angles as acute of their trigonometric ratio. So let's solve the first one. A, we are given that of 289 degrees. Okay, here it means that theta is equal to 289 degrees. Let's draw. We're going to start from OX to measure, and since it is positive, we are going to go anti-clockwise direction. 289. That means we found ourselves in the fourth quadrant. This theta is equal to 289 degrees. So we are looking for this acute value. The formula to convert theta into acute value in the fourth quadrant, remember it is given as alpha is equal to 360 degrees minus theta. So alpha here is equal to 360 degrees minus theta is what? 289 degrees. Okay, so alpha is equal to 71 degrees. It simply means that sine 289 degrees is equal to sine 71 degrees. Now we want to know whether this sign is it negative or positive in the fourth quadrant. Remember, in this first quadrant, all are positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And in the third quadrant, only cosine is positive. So sine cannot be positive in the fourth quadrant. So I'm going to put minus here, and you are done. So what they want you to determine is the nature of the acute value of sine within the fourth quadrant for this value. Of course, it is negative, and this is your final answer. Let's take example 2 for further clarity. By giving cos minus 109 degrees. It means that theta is equal to minus 109 degrees. It is only after you have gotten mastery of this topic that you can use this negative value to just work. But I will advise you to first of all convert to positive. Let us know what is the positive equivalence of minus 109. So since it is negative, it means we are going to go clockwise direction. Minus 109 is more than minus 90. It means we're already in the third quadrant, this very quadrant. So what brought us here is theta equal to minus 109 degrees. So this is it. So I will advise you to first of all get the positive equivalence of this angle if you want to use the formula to solve. So the positive equivalence, if from here to here is 109, it means that from here to here is going to be 360 minus 109 is 251 degrees. So it means we are dealing with 251 degrees. Now we are dealing with positive angle, it becomes easier for us. Of course, so let's now draw. So 251 degrees is more than 90, is more than 180, but it's less than 270. So we're in the third quadrant. So we find ourselves here in the third quadrant. Okay, but our interest is this very angle, the angle that OP formed with the horizontal axis, and this is our alpha. Okay. So in the third quadrant, what is the formula to find the acute angle equivalent? Remember, it is alpha is equal to theta minus 180 degrees. It means that alpha is equal to theta is what? 251. minus 180 degree. So alpha is equals to 71 degree. Okay, so since we are giving cosine, it means that cos bracket minus 109 degree is equal to cos 71 degree. Now let's now know whether it is negative or positive. We are in the third quadrant. Remember, in the first quadrant, everything is positive. In the second quadrant, only sine is positive. And in the third quadrant, tangent is positive. So since we're in the third quadrant, the acute value of cosine is negative. So here it means that theta is equal to minus 4 degree. So let's get the positive equivalence of minus 4 degree. So negative means we go clockwise direction, and minus 4 simply means we are in the fourth quadrant. To avoid mistake, I can work with negative value, but to avoid mistake, let's just get the positive equivalence and we'll now use it to solve our problem. So positive equivalent is from here to this other place. This is minus 4 degree. So what remains will be 360 minus 4. That will give us 356 degree. I can now go ahead to answer the question. So 356 degree is in the fourth quadrant. So let's draw. So remember, it's positive now. Theta is positive now. So we go from this way and we land in the fourth quadrant. And here theta is equal to 356 degree. So we are in the fourth quadrant. This is our P. Our interest is the angle made with the horizontal. For the fourth quadrant, the formula remains alpha is equal to 360 degree minus theta. Alpha is equal to 360 degree minus, what is theta? Theta is 356 degree. So alpha is equal to 360 minus 356 will give us 4 degree. Let's now write tan as an acute. Therefore, tan bracket minus 4 degree is equal to tan 4 degree. Let's now determine the nature, if it is positive or negative. So remember, in the first quadrant, all are positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. And in fourth quadrant, cosine is positive. So tangent is what? Negative. This is our final answer. So I believe that with this lesson so far, you can find the acute angle equivalent of any angle given to you. And you can find the nature of that trigonometric ratio. That is whether it is positive or negative in that very quadrant. Thank you so much for watching. If you have not subscribed, do well to hit the subscription button, like the video, and share with your friends and students, though that this video is going to really help. Thank you so much. See you in my next video.